Hey kids, welcome to lesson 5.9 of this keyword. The keyword this can be used in a class to refer to the current calling object. For example, in the following class person, when we create an object P1, we call the constructor or P1 set email. The word this refers to P1. And when we make the same method calls with object P2, this refers to P2. Run the code below and check out the Java visualizer to see what's going on. And kids, I think we're going to jump over to the Java visualizer to look at this one because I think it's just a little easier to see. Let's step through it here. We go to our new person here. And you can see we have nothing there, but we do have our this name. And we did set the name to Sonia. That means we're going to put Sonia in the name right there. That's our only constructor there. That means we should get a print off Sonia null. And well, that's what we get. Next, we're going to go to person 2. You're going to see we're going to set to this time Jean. So it's going to set our name here to Jean. And then we have nothing there, but we are setting the email. So it's going to set the email. And it's going to, after that, set the phone number there. And then after we set those two, well, we're going to print off that entire thing we just did, Jean at Gmail and the phone number. So as you can see, kids, what I did get printed off was a Sonia, null, and Jean at Gmail, and 404. Let's jump back and play around with this just for a second. Over here, you can see the same thing we just did over there. And if we hit save and run, you will see we get the same output. But what would happen if we just switch this part here with this part? And all of a sudden we want... All of a sudden, we want a person 1 to be first. So we are going to put a bunch of information in there. And we can set the email, and we can set the phone number. And in this one, we'll have just person 2 be Sonia. It should flip-flop because you can see the name this is local for both of them. And that means when I flip-flop this, so should this. I should still get null because I'm not calling to the instance of P1. I'm just calling towards this local part here. So when I hit save and run, you can see it just flip-flopped. That means this can be used again to refer to the current calling object. That means every time we create a new one, we're referring to that instance, not to the greater variable. Pretty important thing, as long as you understand that, kids, the rest of this is a breeze. Note in the code above, this name, this email, and this phone number are equivalent to writing just name, email, and phone number, but this variable is a way to indicate that we are referring to the instance variable of the object instead of the local variable. And if you remember back to the previous chapter, we had that name, and depending on where it called, it went there. So that's just a little note back to that last chapter. Static methods cannot refer to this or instant variables because they are called with the class name, not the object. So there is no this object. Just remember that, kids. It has to be an object. The keyword this is sometimes used by programmers to distinguish between variables. Programmers can give the parameter variables the same names as the instance variables and then can distinguish them and can avoid a naming conflict. For example, both the instance variables and the parameter variables are called name in the code below. And we saw this in the last lesson, kids. We had name and name here. And when we called a name, which one do we want to go to? Do we want to go to our instance variable or to our constructor variable? And that was really the difference there. And we're going to see this here in a second. This variable can be used anywhere you would like an object variable. You can even pass it to another method as an argument. Consider the classes below. Pay and overtime. The pay class declares overtime object and passes in this, the current pay object, to its constructors, which computes the overtime with respect to that pay object. You can try this code in the Java visualizer. Here's an image of what we're looking for. Basically, kids, what it's doing here is we are creating an instance, and then we're creating another instance that's referring to that one. So we are going to add, or in this case, multiply something up here. Let's see how far we can stretch this down, kids. We have our public class pay. We have our private double pay. We have public pay, which is a double P. Pay equals a P. We have a public double get pay, which is going to return pay. We have our calculate pay with overtime, and overtime OT equal new overtime this. So we're creating a new object right there, kids. Pay equals OT, this object here, get overtime. And then if you look down here, we have get overtime. That is this, which is going to be return pay with overtime. And what's pay with overtime returning, kids? Well, this overtime class right here is just overtime. And then you're getting whatever that pay is. So in this, think of this like Sonia name. And then it's going to be multiplied by 1.5. And up here, we have my pay calculate pay with overtime, and then we're going to print off my pay get pay. Well, that means we're going to print off whatever my pay is. And if you remember down here as we work through it, it is just going to be whatever that new my pay is, which is 100. Times 1.5, which is 150. Let's hit save and run. There you go, 150. We just had to work it around. And again, what's this doing? It's just passing this along as we go through. So just remember that, kids. Consider the following class definitions. And this looks just like we just did up there. The following code segment appears in a class other than pay or overtime. Pay 1, new pay 20. And then we're going to calculate pay with overtime and then get 1 pay. Well, just like above, kids, we were just passing this off. The pay object is passed in the overtime constructor. We're going to do the same thing here with 20. 20 times 1.5. Well, if I hit my calculator here, beep, boop, beep, boop, beep. Well, that's 30. That means we should get 30. And again, it's just multiplying there. So the variable is just passed along. Programming challenge, bank account. Create a class called bank account below that keeps track of the account holder's name, the account number, and the balance in the account. Make sure that you use the appropriate data types for these. Write 2 constructors for the class that initializes the instance variables to default values, and 2 given parameters. For the parameters, use the same variable names as your instance variables. So we're going to do something a little different there, kids. We're going to use the this keyword to distinguish between those instance variables and those parameter variables. We're going to write a toString method for the class. Use the this keyword to return the instance variables. write a withdraw amount and deposit amount for the class. Withdraw should subtract the amount from the balance as long as there's enough money in the account. That means the balance is larger than the amount. Well, kids, that doesn't describe my bank account. Deposit should add the amount to the balance. Use this keyword to refer to the balance. And then we're going to test our main method by creating a bank account object that calls its deposits and withdraws and prints off the objects to test its string method. So we just want a tester method there. Woo! We got a bunch to do here, kids. And then we just have our refresher, create a class bank account that keeps track of the account holder's name, the account number, and the balance in the account. Create 2 constructors, a toString method, and a withdraw and deposit method for our account holders. Use the this keyword in the constructor and methods. Test our class. Woo, kids. This seems hard, but really, this is what we've been doing this entire time, kids. This is nothing difficult at all. In fact, this is a good dress rehearsal for our AP exam. Let's start with what the first thing we always do, kids. We're going to create our instance variables. And let's just comment this out. We're going to have our instance variables. And this is just going to be our private string. And this is going to be customer name. We'll have another private int account num. We're going to have a private double and a balance. Those were the things that they want us to keep track of. First, I'm just going to make my public bank account. We should name it like above, kids. Bank account. And this one is just going to be our default values. So that's going to be a customer name is going to be new customer, and then account number. We'll set that to, we probably want something high, right? 1, 2, 3, 4, 5, 6. That's almost 1 million, right? I'm sure you'll let me know in the comments. Balance. Well, we always want to start at 0, kids. And in this one, that's just setting our defaults. Now we should comment this out though, kids. And now we're going to do our constructors. And this one's going to be our public bank account. And we want our string to be what? Well, we are not going to change our instant variables and parameter names. Remember, kids, they want those to be the same from above. So we're just going to do customer name, int account num, and double balance. And since they want us to use the same names, we're going to have to use the this keyword because we need to distinguish, kids. So this customer name is going to equal the customer name from above. So this account num is going to equal account num. And then this balance is going to equal balance. Don't forget your little period there, kids. And that's our constructors. We're using the this keyword to return our instance variable. And we still need to use our toString method, and that needs to print off the name, the account, and the balance. So let's go ahead and do our toString. Whoa, kids can't spell here. And this is going to return this customer name plus, and we're going to have to do a little concatenating here. We want this account num plus we want this balance. And that takes care of the return part. Now, kids, we needed to do a couple of things here, if you remember. So if we come up here, we needed to make sure that the balances were correct. We're going to have to do something with the withdraw. So one, we're going to have to make sure that we can withdraw. So if the balance is greater than the amount, they can do it. And then we're going to have to subtract that balance somehow from the amount. And then we're going to have to do the same thing with a deposit. We're going to have whatever they just put in added to the balance. And this has to be on the this because we want different names for stuff, right, kids? Well, that doesn't sound too bad. If we come down here, let's take care of the tough one, that withdraw. So if we have a public, and this is going to be void because we don't want to return, right? And we just want to withdraw. And this one is going to be double. And we're going to make this the amount, how much the customer is doing, right? And on this one, we'll need some curly brackets here. If, and we'll say what I say earlier, kids, if the balance was greater than the amount, so we'll have to use this word, balance, is greater than or equal to the amount. That means if we got money in our account, kids, well, then you're going to take money out of our amount. Well, then you're going to subtract that amount from the balance. So you're going to take the balance and then minus equal whatever the amount is that you just withdrew. And then that one should be the end for that one. Now we're going to have to do something pretty similar for a deposit. So same thing, a public void. And then we want our deposit here. And we're going to make this a double amount again, how much they're putting in. This one's going to be a little easier, right? Because on this one, we're just going to take whatever their balance is. And then we're just going to add whatever the amount is that they just put in. We should comment this out, kids. Ooh, I got away from my commenting here. This is the deposit. And that's just going to equal what we have plus what we put in. And then our withdraw here, this is a take money out. And that's going to equal, ooh, kids, I have a spelling error right there. The amount minus the balance, but has to be less than the withdraw. So you can't withdraw more money that's in your account. If I have $100 and I try to take out 200, well, that ain't gonna work, kids. So that amount has to be less than the balance. This is just returning my constructor. And there's my constructors there. Looking pretty good, kids. We're not done. Oh, we got to go through and we got to put our print methods, right? So we have to create our public static. So public static void main. We got to do our string args. And in this one, what do we have to do? Well, let's test this, kids. Let's make a new bank account, and let's just call this account 1, and that's going to equal a new bank account. Then we should print off account 1. And when I do that, I should get just account 1 because I got nothing here. New customer 9999 and A0. Let's see our spelling errors, kids. Ooh, new customer. Kids, I was just looking at this. Forgot that. Let's see what else we got. Oh, kids, look at that. As you can see, a new customer came up, 99999 and 0. We can keep adding to it. And this is the neat part of this. Let's add a new bank account. And we're going to call this Roads. And that's our new bank account. And in this one, I can add some parameters into here. Let's say this is going to be roads. And my account number is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. Ooh, we should see how many numbers we have up here. I guess it doesn't matter. And then our deposit amount, we're going to put in $10, kids. And when I go to print off now, and just print roads, I should get this right here, right? Ooh, forgot my semicolon. And there's my account and how much money. So Mr. Rhodes got $10 whole in there. But we're not done yet, kids. We have our deposit amounts. Let's try our deposit, the easy one. And let's just go over here and just do roads.deposit. And let's say I just got paid. I could put in $50. And at that point, after that, let's just print off how much money I should have. And I should have in my account now $60. Ooh, look at that, kids. I'm rich. But kids, you know me. I need a new mic or something. We need to try our withdraw. So that's going to be roads withdraw. And let's try 50 here. And then we'll print off that. And see what happens. And I should end up with $10 again. Uh-oh. All right, let's try this whole code one more time here. Let's see what happens. It should just give me 10 because it should let me do that. There you go, kids. I can't overdraft. Lucky me. The amount was greater than the balance. It wouldn't let me do that. Now I can keep adding people to this, kids. Let's try a bank account. And this time, let's try score. And we'll do new bank account. And this time, we'll do Mr. Score. His is probably pi 3.14 kids. Whoop. Has to be a int. And then his amount, well, Mr. Score is going to start off with 0 kids. And now we can, anytime Score does a deposit, let's make Mr. Score rich here. And then we print that off. We should, there we go, get our numbers. So this is, kids, kind of like how your bank is created. Every time you go in, you're just adding new stuff to different or variables or changing the construct. So pretty neat, kids. Next time you go to the ATM, just think of what you learned. We have our summary. When a non-static method or constructor, the keyword this is a reference to the current object, the object whose method or constructor is being called. This instance variable can be used to distinguish between this object's instance variable and the local parameter variables that may have the same variable names. Static methods do not have a this reference. Because remember, with a static method, you're calling directly towards the object. This is referencing an object. The this variable can be used anywhere you would use an object variable, even to pass it to another method or argument. That's just pretty important, kids. Just remember that. We have an AP practice question. Consider the following class definition. We have our public class liquid. We have an int current temp. We have a liquid, which is the integer CT. CT is current temp. We are get current temp, which is just returning the current temp. And then we have some void, which is adding to jar. We're adding to jar whatever this is. So we're going to get something passed up here. We have another private class liquid jar. This is a total temp. And we have a liquid jar total temp equal 0. We have another void here, add liquid, and that is the total temp here. And then that is just adding whatever the current liquid is, and that liquid is just getting passed down from there. And then finally, kids, we have an integer get total temp, which is returning a total temp here, which is back up here and here. So you can see it's returning a couple different places. Consider the following code segment which appears in a class other than liquid or liquid jar. We have liquid water, new liquid 50, liquid milk, new liquid 15. Liquid jar J is a new liquid. We're adding to jar J. Looks like we're adding 50 to our J, and it looks like 15 to J, and then we're printing it off. What if anything is printed after the code is executed? Well, we have some numbers up here, kids. And if you look, get total temp is the total temp plus the current temp. And it means all we're really doing is just adding these two together. 50 plus 15. So if you see, we are just adding those together. That should be 65. And there you go. Liquid with a temperature of 50 and then liquid with the current temperature of 15 is added. And the current temp, we're just getting those temperatures passed down here. And then we're printing off of the total, kids. Well, that's it. Hopefully you found this video helpful, kids. As always, if you have any questions, let me know. Otherwise, I'll see you on the next video, kids. See you later. Bye. Bye.